Hello. Yeah. Hi. So it's been a long time. I guess I missed a day and didn't want to miss today. So you can see the time. This is 5:49. So I'm still stuck at that place. Uh, that is the exact thing I don't want to. So I'll look at the solutions, ask GPT if I couldn't do it, and try to get into depth of the solution. Okay. So I'll just try it first myself, and then we'll see. So I actually didn't want to miss this, so I'm doing it. Otherwise, I would have slept. Now, yeah, let me share my screen. So proper recursive solution. So if I forgot, if or someone else forgot, mm, this is about this exact solution. Not solution, the problem. Maximum subarray. Sum of contiguous numbers in a given array where it's going to be maximum or what, not indices but total sum. Okay, so if it is in this one, indices one, that is going to be two solution into one, right? But I'm not going to talk about that. I'll be keeping my mind at this one only. I'll copy it. I'll copy this example. This will help me. This will help me in dry running the solution if I am able to write one. Okay, so later we'll see. So from here we'll start, zoom in. So a proper recursive solution is right now our function is like we want to, like, let's visualize the brute force, right? So in brute force you will make one for loop, then another for loop. First one will go to the first one will scan from this point to entire array, then second time the loop will start from here, then third time it will start from here, then fourth time it will start from here, and we'll try to sum all the elements and take the maximum of it, right? So the recursive solution is going to be a little different, I believe. It is about to choosing and not choosing. Suppose if I choose this, then I'll have to choose everything. If I leave this, I can choose any one of this. That is the point, right? So I mean, if I have chosen something, um, if I have chosen something, I do not want to skip anything else. But if I have not chosen, then in that case, I would like to skip, right? So let's say it's this is a recursive function, okay? Max is sum on short form MSS. MSS. Okay. So MSS, we are giving a vector that is array int arr, and what else I will look at if I'm choosing or not. So one boolean bool choose pick. Let's say pick, and the other one should be int I and inx. It will show the index, like it will denote the index. Okay, so if I n x equals, and suppose the n is arr dot size, so we'll just return, and in else no need to write else. You're getting my point, I believe. No need to write else. Let's start from here. Whatever we write is else only now. So we'll see if pick, right? If pick means if pick is false, suppose if pick equals false means we are not picking that element currently. So what we will do, uh, we are not picking up the element, then we will just call mss vector int arr bool. Let's say there's a global variable sum or something. I guess we'll need some global variables. Int sum, fine, and there will be one global variable int answer equals 0. We will keep this. Maybe we'll keep this, or maybe we'll not. Maybe yeah, we will. So we are going to choose the next one. So bool comma inx plus 1 comma if we are skipping the current element, right, then we will just pass the sum as it is. I believe in else part, this will be, I'll see the actual solution before after doing this. So after that I hope I will be able to understand it better. So in else part, answer will be max of, okay, I'll just check out the actual solution. I'm just basing it off from my memory and whatever I understood. So let me see. I'll check in this directly. Max array lead code. Here we are. So this is the problem. Yeah, I've done the solution. It is correct. Go to the solution. Go to the Abhishek Bhai solution. He's the only one who has written it properly. This one. So, based of this solution, I'll try to understand it. So here, I can maximize it. Yeah, fine. Turn off the stage manager. Slide. Let view. Left split. This is just bad. Maybe I can just slide over. And why not in this mode I'm able to do it properly. Okay, I'll just take a fucking screenshot. So, okay, so in this one, I'll try to understand the solution and what was the motive behind it. So, if size is greater, then yeah, this is same as mine. So, it is just returning must pick. Or not must pick. It is returning, like, if this one is true, right? And so we must contain at least one element. If must pick is false, and then is no element. Okay. If array has no element and must pick is false, means all right. This is a corner case maybe. Let's see. It is trying to say. If must pick is fault at end, means no element is picked, and this is not a valid test case. So alright, if must pick is fault at end, like must pick should be true at some point at least. So if it is true, then only it will pick. You can see, and the scene is here. Okay, so must pick will determine. Let me write it down so I won't forget in later time as well. Must pick is false, then there is no valid solution. No valid solution means, I guess, the least negative number you can pass, right? Still, no, this is not valid case. Okay, it is saying our subarray must contain at least one element. Alright. Okay, got the point. So we are setting the must pick, we are sending the must pick as false itself. Not no valid solution not. So this is the check. Like if there is no, I'll draw with this. We are sending it as a false, right? And if it's false only, right? And I is already greater to or equals to 1, the size of the array. Okay. For one time it will, if it is initial, the first call of this function itself, and must pick is already false, and this is happening, then we will it is just returning, right? So the first instance of the this call will directly return. There's no more calls to make. So if you send 0, it makes it look like there's a solution that sums up to 0. This is the maximum sum, but no, there was no element in the given array, so it will return 10 to the power minus 10 to the power 5, I believe. Yeah, this is what it is. Yeah. Now let's say if I is greater than equal to size a. Okay, we have passed this, so this case will not appear. We are sure about that, because otherwise how will we test, right? So okay. Yeah. Later we will look at it. Right now, let's focus on this one. Yeah, the other part. It must pick is false, so must pick is not going to be executed at the first part, and it will get executed in the next part. That is this. So let me number these lines. 1, 2, 3, 4. 4 lines are here. So yeah. So let's
start with the stack. So if it will call this one max of I plus 1 comma a of I plus 1 solve I plus 1 true. Okay, so here at this call we are not picking that element, and at this call we are picking that element. Okay, kind of I'm getting the sense now actually. So here we are picking the element, here we are not picking the element, and we are taking out max of these, whoever going to give the max solution. So let's start. We started with solve. So this will not do the justice. I'll start from here. We have started with this one. This is our root. So solve. Let's call it nums, or just a of 0, not 0, let's keep it a for now, then 0, that is this one will be index array, and last one is false. Pick boolean. So yeah, this is why I have made curly brace, I have no idea. Now yeah, we are here. This is the root node. Then we'll cast a straight line. So it will make two calls. First call is going to be solve a of I plus 1, we are going to do I plus 1, then false, that we are not picking the element, means we are not adding it as well. But now if we are picking it, a of I plus solve a comma I plus 1 comma true. Let's say it is this array, so 0, 1, 2, 3, 4, 5, 6, 7, 8. So now in place of doing I plus 1, I will just do 1. I'll put it actual values here from the example, minus 2, 1. Now we'll do similarly for this. It will be solve a of 2 comma false, we are not picking. Next, obviously we will be picking in this call. Solve a comma 2 comma false. This is something like we are starting from second index this time, not the first index. So second index will be second index is 1, so 1 plus. Again here we'll calling it similarly. So left side will be we are not going to we are not going to pick the element, that is solve a comma 2 comma, and this one is going to be true, sorry for that, a comma 2 comma false, and now the other one will be picking the element, and that will be minus 2 plus 1 is going to be minus 1 in total. Should I show here? Yeah, I should show here. So minus 2 plus 1, because yeah, minus 2 plus 1 plus, so we solve a comma a comma 2 comma 2. Okay. So it will, I'll show it as minus 1 at the end, like this. Now further this will call these two are going to be the same, right? This subproblem, that subproblem, feels like, but going above it will change, it will divert. Now let's, anyhow I'll do. So another will be, if I don't have space I'll just move it. That is the only reason why I bought a tab. Yeah, so yeah, for this one we'll be having this solve a comma 3 comma false, and another one will going to be solve, and this will start from third index, that is minus 3, minus 3 plus a comma 2 comma 2, and this will be solve a comma 3 comma false, and this will be 1 plus minus 3, right? So if we are not propagating this value here, why we are propagating there? That is one of my question to myself. It is like we have picked, right? Then why he has made one tree as well? I'll check if I'm making it correctly. I don't want to waste my time. So he has made, okay, all right. So true of true, those are repeated, and f1 of false and 1 of true. Let me check mine. So false and true, then we have true and true, we have false and false as well. I believe that false and false should have been the common one, but okay, suppose our array has only 4 what do you say, only 4 digits. Okay, so we are at, and we need to go to till index 4. That is fine and all. So let me do it. We'll think about it later. Just a minute for this. So we'll be having 1 plus 1 minus 3 plus solve a comma 3 comma true. Now we'll have to separate a little, like from this. Yeah, this is better. And this one as well. above, so it looks on level. Yeah, now this is fine. Yeah, now this one will be called, this one will be solve. Let me zoom in. Solve a comma 3 comma false, and the last one solve, let it be a 3. Okay. So maximum sum subarray. Let's make it in place of -3, make it 2, and here -4. So maximum subarray sum will be 3, and that will be 1 to 2. So let's begin about this. Alright, so when we are at index 2, so here we were at index 0, no, let's see, alright, there is one problem which I have done. I have not looked at the problem properly. Okay, I'll just remove this tree, all this tree. I hope I'll do it properly this time. So let me remove all this and this. Okay, and this and this and this and this and this and this and this. Now I'll do it properly. So the reason was, when I'm saying it is not proper, because for the positive side, like for true side, it is going to be different. So yeah, let's start again. I have this solve a comma 1 comma false, that is fine, and we are going to have solve a comma 1 comma true, but we have called it with a of I plus 1, right? So it is going to be plus minus 2 here. Now the false one will expand, obviously. So false one is going to expand like this, solve a comma 2 comma false, and this will again call with a of I, that is 1 plus solve a comma 2 comma false, I mean true. Now for the true, we are going to do something else, right? True one is going to return something else according to line number 3. It will do this, it will call a of I 0 comma a of I plus, so minus 2 comma, here we are going to do minus 2 plus 1, minus 2 plus 1, plus 2 plus 1, I'll have to do the max of, I mean, we'll do it later though. If it is not, we'll have to evaluate this function before doing the max calculation, right? So we know if it is less than 0, we'll just take the max of it. So 2 comma 1 plus I can say plus solve of a comma 2 minus 2 comma 1 plus solve of a comma 2 comma true. Now whatever this thing is going to give, this is also going to give. It is what they have mentioned, I believe, in their tree. So now finally understood. Whatever this is we don't bother, but these two going to be same. So I believe these will not propagate with it, hopefully, like downwards, right? So there's no point of propagating downwards. So it will be just 1 plus solve, and this will again just 1 plus solve. We'll see if it does propagate or not. If we just write it for now, we are at 1, we are at 2 already. So we are writing for index 2, we have done for 0, 1, 2, and we'll do for, okay, this is index 2. Okay, it is calling this index 2, not, it is not actually 2. Let me think about it. So we are giving a of I and calling I plus 1. Yeah, we are giving a of I and we're calling I plus 1. That's fine. So we will call a of 3 here. Solve a comma 3 comma false, and this will be what we are going to do here is at index 2 what is there. So at index 2 it is 2, so 2 plus solve a comma 3 comma false. Now I'll have to do this, and this is going to be 2 plus solve a comma 2 comma true, and this is not going to be false, sorry, sorry for that. So this is true, and now we will be calling this true again. So this will be again 2 plus solve a comma 2 not 2, 3 comma true, and so on. For this false one again solve a comma 4 comma false, and this one will call for index 3 what we have, minus 4. So minus 4 plus solve comma a comma 4 comma true, and similarly it will also do the same thing, minus 4 plus solve a comma 4 comma true. Now this one will do the same thing here. Minus 4 plus solve a comma 4 comma true, and this will also do the same thing. So minus 4 plus solve a comma 4 comma true. Now yeah, now I'll just highlight the similar problems. So I'll highlight at the top level itself, so that I'll solve only one. So essentially this one is same as this one, subtree we can do only required. Then I can do this one similar to this one, similar to this one. Then all these four are similar. These all four are similar. So next iteration will obviously give us what? If it is false, right? If it is false, let me check. So it says if it is false and size is equals, line number 1, right? Line number 1 of the code, what it says. If I is greater than equal to size of A, yeah, correct, it is greater, it is greater than equal to so size of A is going to be size of A. Okay, I'm a little confused now. So size of A, it is saying it is if it is greater than or even equal to. So if it is even equal to, that means this, right? That means this call. Then the further thing will not happen, I believe. So this will not happen, and this will not happen as well. So we will just return from here, and this will be returned as -1 E5. And if we recall this, so we are going here, so -4 plus 0, we are doing -4 plus 0, okay, max of -4 plus 0 comma 0 max. So we are getting 0 here. In between both, we are doing max of -1 E5 comma 0. So we are going here, we are getting 0 at this place again. Now this will again give -4 comma 0, max will be given as 4, -4 comma 0 max. So 0 will be given again, 0 comma 0 max, okay, 0 comma 0 max will be again 0 only. And now we are doing it here, so this is going to give 0 comma -4 as 0. Yeah, so 0 comma 2, it is going to give 2, 0 comma 2 max, it is going to give 2. And I mean, you can see here, right? It is actually adding it as well. So whatever we are getting, we are adding as well here. So after like, but the value which is returned is 2 na, so 0 plus 2 it is going to be, so it is 0 0 plus 2, okay. And we are, I mean 0 plus 0, so this value is given as 0 in return. Then what do you think this value will give? 0 only, right? So 0 0 comma 2 max, we are getting, no, 0 plus 2 we are doing, then we are taking the max. So here a of I is going to 1, so I want to do it correctly, okay. Well, I'll do it from the beginning then. Here -4 plus solve of a of I, it is written. I'll press C and do. So -4 we have plus solve of a of I. We'll be doing max. The function will be there always, this one. So max of 0 comma a of I plus solve of this. So solve of this is 0. Value of this is 0. So value of this is 0 and we are 0, then minus 4 plus 0 equals 0, 0 not 0, minus 4, then we will do minus 4 comma 0 max and we will return that, and max is 0, so this value is 0, so 2 plus 0 equals 2, and we are doing max of 0, right? So max of 0 comma 2, we are getting 2, so this value here is 2. Again now 2 plus 1 we will do 3, and we are doing max of what you say, max of 0 comma 3, so max of 0 comma 3, so we are getting this value as 3, so we also have one max variable, okay, some kind of answer variable, maybe. Let's see if we do have. No, we don't actually. Okay, this is a little confusing at the end. We got this value as 3, right? If we have kept one something like this answer, we would have got the answer as 3, but now as the value we are getting is 3 here, okay. So the value which we are getting here is 3, and the a of I is minus 2 at this time, that is value of a of 0, so we will do 3 minus 2 equals 1, and okay, so this value is 1, 1 comma 0 max, answer is 1, so final answer it is returning is final answer it is returning is 1. Let's type this code out and let's see if it is actually returning 1. For smaller answer it will, if we are making any mistake, so yeah, if we are making any mistake we'll just try run and check once again. See, this is going to take too much time, that is why I guess I was also delaying that. So let me just start my laptop. Yeah, so let's go to lead code. Profile. So one I'm attempting 54 submission, we'll see it later. Now I've done this maximum subarray. Maximum subarray. All right. I'll try that solution, return sol. We are taking
nums here, comma the index, comma if you want to take it or not, right? So we have this, not the sum variable, not index is fine, and this will be bool pick. If uh, if nums dot size nums dot size is less than, so I mean if it is, yeah, less than equals to I, if like I is greater than equals to nums dot size, we will return based on pick. If pick is true, right, then we will be giving out 0, or if pick is false, we will be returning 1 minus e5, so, or int main, hopefully. Now if this thing is true, like if pick is true, we will do return return max of max of 0 comma nums of I plus sol nums nums comma I plus 1 comma true only, yeah, otherwise we'll just return max of num, I mean sol nums comma I plus 1 comma true, false, I mean. Okay, false, comma nums of I plus sol nums comma I plus 1 comma true, correct, and I think that is it. We can try to run it. Okay, these things are running. This will give TLE, but in my dry run, why it is not working? Why? Let's see the solution here. So it is saying so it is saying at index I we can either pick that element or not pick it, and if we pick the current element, then all future element must also be picked, since our array needs to be contiguous. If we had picked any elements till now, we can either and further recursion at any time by returning sum found by till now, or we can choose current element and recurse further. That I got now, how it is doing. So in the code below we will use must pick to denote whether we must compulsorily pick current element. When must pick is true, we either must return 0 or pick the current element and recurse further. Yeah, if must pick is true, we either return 0 or we select the current element and recurse further by continuously selecting all other elements. This is the special case, I guess, and this will be to take and not take all the elements type of recursion here, with the special condition like a plus 1. Otherwise this true and false will be pick or don't pick kind of condition, right? So that's there. Now now we'll take a look at why we are not getting this. So in the code it says return max of since this is in the stack, right? So we are doing 4 plus 2 plus 1, then suddenly minus 2. So we are always returning max of it, right? But we are always, before returning max of it, we are adding a of I. So do I want to visualize this in such a way the execution cycle is going to be little like we'll see. I can try to execute, I can try to get the value as I'm not saving it, but I can save it and then compare it, right? So whatever value I'll get, I can save it, then compare it. So you're doing max of each time. If you don't do max of this and that, we can print it. Okay, I have solved for this left one. Why I haven't solved for this right one? So we are getting minus 4 plus 2, minus 4 here, right? So minus 4 is the value of this. Minus 4 plus 2 going to be minus 2, then minus 2 comma max comma 0. Anyhow, alright, I believe I got the answer. Let me, I'm sorry, I'm really sorry. So max of this, we are going to get 0. So we have 0 here, and then see, this will be the answer. This is correct only. This will be the answer of if we pick 2 and continue till like if we started from 0 and continued picking the element till I guess minus 4. This is that, okay.
Now this one will be if we pick the element at index 1, right? This branch is doing from this branch, if I say correctly, this branch is doing from index 1 to 3. This one is doing at 0 to 4 for everyone. I mean, I believe this one will be, no, actually, yeah, this all will be here to here, 0 to 4. This also will be 0 to 4, but from here to here this is going to be 1 to 4, like that. This is also going to be 1 to 4. Getting a point what I'm trying to say. Yeah, I guess, I hope. And if there's anything in doubt, just post a comment in comment section and I'll take care of that. So here, let's see, this one will be returning 0, so it got 0 here. Now see, what I'm trying to say, we don't have -2 here to destroy the destroy the answer here. So that's the good thing, right? Because we have not picked that fucking element here. That's the difference. Okay. We can understand it many ways, but this is fine for now. So we got 0 here. This is the value 0. 0 plus 2 is going to be 2. So max of 0 comma 2 is going to give 2. Again, this value will be 2. Then 2 plus 1 is going to be 3. Then max of 2 comma 3, sorry, 0 comma 3 is 3. So this value is going to be 3. So we have nothing to add, right? Yeah, we are getting 0 from this. Then it will be just max of 0 comma 3, and this will be the value 3. Now we have this final thing, so this will be written like max of 1 comma 3, and that will be 3. So answer finally. Yeah. Now let's think about it. So we have many overlapping solutions here, and one thing is how he might have thought of the solution. It says like we either pick or we don't pick. So we created this pick variable, and then we are going through this maximum, whatever it is going to be the max, right? So when we pick, we should not stop, we should keep picking. It is not like we pick and we stop, we pick and we stop. If we have picked, we will keep picking. This is what it says. That is why we have this return statement here. If it like one branch of it, it says like if the one branch of is true, it will keep it as true and we will just return it, not make two calls. We are not making two calls if we picked. That is, if we picked, we keep picking. Fine. And next thing is, if we are not sure, right? Like there was one thing, this call. This ensures that we skip as well. So this call will ensure that we are skipping in the systematic manner, and then yeah, if we are picking, we are picking. If we have skipped, we'll skip, and then we will start from another index and we'll keep picking. And a plus I, just we are adding this. A plus I is a special case, right? I'll just talk about it. So this a plus I this AI is added and max function is used for this specific question case. This is what I understood till now. If it is different, we'll see. Okay, in future I'll come back to this point and make a correction. Hopefully I will see more recursion question, and at that time I will able to get a solution myself. Let's see. I'll explain this solution to many people so that I can get a grasp of it in a better way. Okay, this was a huge win for me to at least understand this question, so this is a reason to celebrate, hopefully, for me, as work is not going very well for me right now. It is a little difficult, so yeah, we have cracked this one. This solution at least I have cracked for myself, and you can see we have done so many things in rough till now, right? Yeah, this solution, see this, this is a nice solution. Hopefully I'll just remember it. I'll read it once again, or do the maths behind it. I'll at least explain someone else so that I keep it in mind. Maybe I'll grab Yash for this. And this was to find the diameter, right? Yeah. So in my bucket I had some things. This question was one of them. So maximum subarray I have done contains duplicate. This doesn't. This isn't available. Analyze diameter of a tree. Solution on tree. Solution on tree stack. Also max depth of a binary tree I have to do, and try to implement it in iterative way, that is stack. Done. I'll do it later, though I'll keep it in my mind. I have to do the DAC of this as well, this proper recursive solutions DAC. Before DAC I'll try to implement that memoization solution. Okay, so let's do that. Okay, so let's do that. So memoization, whatever it is. So we have seen the overlapping things right here. So whatever is true is most probably getting overlapped. So so we need to, there's a redundant thing. So whatever in must pick is there, this redundant calculation can be implemented to store the results for a given state and reuse them later whenever required, rather than recalculating them over and over again. So we can say if we have must pick, right, dp of must pick, like if it is true and at index I, we can get that answer. So he has created a 2D array. So so it has created this dp2. I believe like it wants two arrays, and two arrays, both of them arrays going to be the size of nums,
and going to be initialized by -1. So there are two arrays, okay, with -1 in between all of them. Now one array is for, I believe, then must pick, and other is going to be, yeah, I think it is. The first array is for must pick is going to show the zeroth index, and if it is false, and if it is true, it is going to show the first index, 0 and 1. So it is what it is doing, trying to write it in a clever way and try to access it in a clever way. So I am happy that I got it. Now, yeah, in that case, let's do it now. So I'm going to create this exact DP, that is fine. So yeah, let's copy that. So we have this. Now I'll try to do remaining things. Command DP. Now here we'll just use it. Now this DP how I will use is if pick, right? So I'm not looking at the solution. Okay, so if pick is true, we'll try to save this solution into the DP. That is the one thing which I want to do. So to return and to save it into the DP and then return the DP array. That is what I want, but I cannot return a DP array, but integer. Yeah, where I'm going to store that DP array, right? So yeah, I'm now looking at the solution. Yeah, correct. So DP of pick of I and equals this. So we are storing this, and yeah, now we have stored it. Before calling any of this function, we would like to use it, right? So if there's like, if it is not empty, if we can do this, right, is not equals to -1, that means it is not empty, then we'll just return whatever they wanted. So yeah, if it is not -1, we are returning. Yeah, let's run this one. Okay, let's see what is the error. It is saying sol and true. Okay, we are not passing on DPs. DP and DP. Yup. Okay. Okay, one more DP. I'm sorry. DP. I think this will pass. This will submit. Shouldn't get TLE. Yup. So I'll tomorrow explain this to Amit, so I don't forget this. Hopefully, if I just explain it to him. The last solution which I wanted to see was the last solution which I wanted to see was cadence, no, actual tabulation method, right? So tabulation method, do I really want to see it? So we can deploy the similar logic in iterative version as well. Fine, right? See, similar logic. This is the actual reason that I wanted to learn, right? So yeah, it is here now. Since I wanted to learn this, uh, let's focus on it. We can deploy the similar logic in iterative version as well. Here we again use DP array and use bottom up approach. Here DP of 1 I denotes the maximum subarray sum ending at I. Okay, including nums of I, and this one denotes the maximum subarray sum up to I may or may not include nums of I. At each index we update this as max between either one choosing current element or extend the previous array choosing the current element as well. Similarly, can be updated as max between. So yeah, you got the point, but you still wanted to got the point, but you still wanted to do some little bit mehnat here. So it has this DP, and at DP of one is going to 0 of 1 can be updated at max between maximum subarray found till index DP of I minus 1. Mm-hmm. So here, how it is getting inspiration from that one? That is, I'm not like this one. This is not clear to me. We are picking and not picking here, so that's clear to me. I guess yeah. Now I guess I can see. I can see that. We can again use DP array and use bottom up approach. Denotes the maximum subarray sum and get I, including nums of I, and this denotes maximum subarray sum up to I may or may not include nums of I. So may or may not include. At each index, we update DP of 1 of I as max between either only choosing the current element, nums of I extending previous array, or choosing current element as well. Like again, this one I can only understand if I do the dry run and then make the connection in between them. Like I'm not able to make the connection between them. Why, I don't know. Maybe I'm tired. This is already 6:30, or maybe I'm confused about the solution still. Don't know. I don't think so. I'm confused about the solution. So here we remember, like, we are going to a tree. This tree is going to be the right side and going to make it skew. We are not calling anything further. um, you're going it at a skew perspective, and here we are. The false call will take us here, and we'll go explore the both of the case. Either we pick or we don't pick, like that. And then if we pick, we just keep picking, and then if we don't pick, again either we pick and we don't pick. This I got. And then it's DP approach also I got, like how it is going to do. So DP will have the pick logic and didn't pick logic, pick one both. So if we have picked, that means it will store at 0th index, okay. And if we haven't picked, then it will store it first index. Though do we have seen where we could have reused the false thing? Let me check. uh, so true is not calling the false one, right? And true is not calling the false one, and false is always going to call the true one. But um, what if we remove this one? In case pick is false, we are not storing it, but we are not using it either. What I'm trying to say here is that if it is false, right, and see if it is false, let me check, and let me submit it. Yeah, right, correct. So there's no need to keep the wrong one here. I mean, we only need to store the correct ones. So I did get the solution. Okay. If I'm doing anything wrong, please point it out. Hopefully, if someone's watching till here, will point it out. Now, let's go back to the solution. Uh, Similarly, that is why I'm not able to understand this one. So we have this 1 of I, and we have this 0 comma I. So both of them we have see, it is only returning back of this DP, okay. So that is what I'm trying to say. And so DP of 1 of I is going to be always like DP of 1 of I is always going to be like either the current element is greater than all the previous sum whatever we have done, okay. If the current sum is greater itself, that means whatever we have sum till now is going to give less than whatever we have currently, okay. We are going to choose the current one, right? This is what it is saying. So this can be done in the single array DP, though it is saying it is taking the it is taking the inspiration from the previous solution. I may or may not agree to this. All right, maybe I'm getting it now. This is yeah, this is similar to previous approach maybe. Um, or maybe not. Yeah, this is kind of same. See, let me undo the changes so you'll able to make the difference. The first one is same as this one, the last one. Okay. So what we are here doing is here we are adding nums of I to the whatever we have in the following call. It can be true and false both. Okay, because no, this is going to be true only. So yeah, that is again a little confusing. Plus this one to this. In iterative version as well, how much time it has passed? 122. Okay, so we can employ similar logic in iterative version as well. Here we again use TP array and use bottom up approach. That's the maximum sub array sum at ending, including nums of I, and plus maximum array sum up to I. H in each index dp of 1I as max between either choosing the current element or extending from previous subarray and choosing the current element as well. Okay, okay, got it. Extending from previous element and choosing the current element as well. Similarly, can be updated as max between maximum subarrays found till last index, that is this, or maximum subarray found at current index, that is this. We are reusing this. Okay, got it. So after adding it up, okay, after adding it up, we are checking if in this one we are checking if it was better before, because we are not checking here, so it is checking if it is was better before here, if it is was better before or if it is better now. That is what it is checking. And here it is checking if it is was better before um, plus current element, or current element is itself is better. So if current element itself is better, suppose, then it will store it, right, and then it will try to see. So this is kind of useless here. Let's see if it is same as this approach, the recursive approach. Kind of different though, not exact inspiration, but still I can see the relation between them. I can see it. Yeah. Cadence algorithm, I can see what what I'm saying is this is cadence. Yeah. And yeah, he's saying we can actually do it with just one row as well. We denote as the maximum subarray ending at I. We can just store what so here we have created this, and we are checking if nums of I is better, or if I add it to like nums of I. Is that better? And any of that is better, we're just storing it to the I. Means if we are adding nums of I with the last element, it is giving us a negative number or something. So we will check if it is less negative, more negative than nums of I, and then accordingly we will keep. And if we keep doing that, this is again just cadence algorithm. Now cadence, if you see, same thing. In the DP we are checking the max element here, though it could have been written a little better, but yeah, this is fine. Like we could have just kept a variable to keep the max of DP of I in a given point, but yeah, this is fine. Max comma DP of I comma max, like that, max of DP of I comma max, like that. So we could have avoided this one, but yeah. Now the final thing which is remaining is divide and conquer. I believe that much time should not be spent on. I have spent a lot of time on it. Now I am at divide and conquer. I'll update it like DFC approach how now. Like I'll comment it out. This one is not done. This contains duplicate, I can remove, and this one should be one it's again cell. So analyze diameter of a tree, also max depth of a binary tree. Yeah, I need to actually analyze both of them. So let me revisit the solution about it till I am here. Grind. See, seriously, I have a gay friend who has used it. I always forgot to remove the history. So please, huh? I'm not gay. He was gay. Diameter of a binary tree, and here we are, diameter of a binary tree root, interest. We are updating the result, and that is valid. Now we are going in the depth of left side, then we are going in the depth of right side, and we are putting val equals max of val comma left plus right, and we are returning 1 plus max left comma right. I guess I have done the dry run for this, I believe. Yep, let me check on my iPad. This seems like I have actually forgotten it. I'll check.
Okay, not done properly. I have not done it. Is in to do still. I can see in my iPad. I've put it into to do. Then I came to this monster question of subarism. All right. So this tree question is in to do, and it's morning now. It is light theme. That's why I think. Okay. DFS node into parallel. So yeah, here we are just talking about getting the value right. So value is like the height of the tree from left side then right side. Now we are using this value. How? I'll see. Just give me a few minutes. So if node int val, we are returning the value at last only. So whatever we are going to call each time. So each time we are going to get returned at line number 19 left comma right, and it will give 1 plus max of. Okay, so max of left side or right side, whatever it is calling. And before that we are whatever we have on the left side and right side of it, we are trying to take the max from the val. So I kind of understand it, but once we do it in the tablet, we'll check what else is there. Let me just check properly. Yeah. So analyze diameter of a tree solution and also depth of a binary tree and try. So I'll first do the depth of the binary tree and then the diameter. I'll keep this in stack for now. I mean, we'll do it. This is a kind of interesting problem, and I'm very good now in doing like dry runs, right? So yeah, I'll keep it in mind to do it. So let's see how it goes. Let's see how it goes. Yeah, I can stop the recording now. I guess too much. This is too much for today. I'll do it tomorrow, remaining after I finish my company's work. I'll focus on it. I also have to focus on what you say. I have to focus on that thing. System design. Some part of Spring as well. Some part of Java, core Java as well. There's many things to do, but yeah, let's do it.